Product rule of probability. So to learn product rule of probability, we'll start from where we left in the last lecture, that is after learning the sum rule of probability. What is the product rule of probability? Let us start with a conditional probability which says what is the probability of y taking the value yj if it is given that the value of x is xi. That is, I'm telling you x is taking the value xi. This I'm already telling you, which means all these other parts, all these columns, these are not in the picture now. Only this one column is in picture because I'm telling you the value of x is fixed. It is xi, you already know that. Now, what is the probability of y taking the value yj? What is the probability of this happening, right? So how do you understand write probability? The fraction of times this particular event occurred out of total number of trials. Here, what is the total number of trials? X equal to xi. How many times did it totally happen? Qi times, right? So you take that Qi here, Qi, and out of these, how many times did y equal to yj happen? So this means y equal to yj given x equal to xi. So x equal to xi is what you are told, that you are told that the value of x is xi. We know that. Given this information, what is the value of y equal to yj? That is the probability you want to find. So x equal to xi, total occurrences qi, you know that. Out of which, how many occurrences did y equal to yj happen? That is this particular box. Let me take some other color. This particular box, this is where y equal to yj happened along with x equal to xi, right? So that particular box represents a numerator, that is nij, nij. So our numerator is nij. So probability of y is equal to yj given x equal to xi is nij by qi. Just keep this information there. Let us derive the product rule of probability. For the product rule of probability, we are going to find the probability where x equal to xi and y equal to yj. So let us say probability of x equal to xi and y equal to yj. You know this from the previous lecture that the total number of occurrences is n, out of which how many have x equal to xi and y equal to yj? That is this, right? Nij. So nij. Nij. So total is nij divided by n. So what is the other way I can reframe this? I can reframe this as, instead of writing nij divided by n, I can also write it as nij divided by qi into qi divided by n. This is also right. You agree with this? That is, I simply put a numerator qi and also a denominator qi, which should cancel out. So instead of nij by n, I wrote it as this, nij by qi into qi by n. Now, what is this value, nij by qi? That is here, right? And what is qi by n? Qi by n, you know, is the total probability of x equal to xi happening because, see, this whole column has x equal to xi and the total number is qi. And what are the total number of trials? N. So by that logic, this value qi by n should be the total number of occurrence in which x equal to xi divided by total number of trials, which is probability of x taking the value xi. Which means you can write this as probability of y equal to yj given x equal to xi. Where did I get this from? Here, okay? Into probability of x equal to xi. So this gives you the sum rule of probability. Let me write this neatly after removing all these. Okay, so the sum rule of probability says probability of x taking the value xi and y taking the value yj can be expressed as this term, that is probability of y taking the value yj, given that the value of x is xi, into the probability of x taking the value xi. So this is the product rule of probability. This sum rule and product rule, this forms a very basic of probability, so you need to be very clear of this. Another way of expressing this is that by removing all those cluttered statements, you can simply say p of xy is equal to probability of y given x into p of x. So this is a very simplified form of writing probability, the product rule of probability. So now you should be clear with the sum rule of probability and the product rule of probability. So the next step is understanding Bayes' theorem.